Hello everyone, today we'll solving the question count nodes equal to the average of subtree. So here in the question it is stated that we have been provided the root of the tree and we need to calculate the nodes which are equal to the average value of the subtree. So here the subtree includes the root as well as its children, descendants we can say. So in this example, we can say for the element 4, I am having 8 plus 5 plus 1 plus 0 plus 6 and I need to include 4 also. So total number of elements here are 6 and the total sum is 24. So 24 divided by 6 which gives me the average value as 4 and yes, the average value is equal to the roots value. So here I'm going to increment my answer by 1. Similarly, we need to go through all the nodes and calculate the average value, and we need to predict that whether the value of the average value is equal to the roots value or not. If yes, we need to increment the counter, else we need to go on through the descendants. So in order to solve this question, we can see this. So whenever we are having these type of questions, we can we can store the answer right from the children. For example, we are going to send the root and we need to get the left sum as well as the right sum. So for example, for this element 8, the left sum is 0, the right sum is 1, and I can easily calculate the current sum, which is 8 plus 0 plus 1. And the number of elements are also simple. They are 3. One from this side, one from this side, and one itself. So more precisely, when we consider 4, when we look at it, we can say the left sum is 8 plus 1 plus 0, which is 9. For the right sum, we can say this is 5 plus 6, that is 11, and current element is 4. Also, the number of elements here is 3 plus 2, 2 elements here, 3 elements here, and 1 itself. 1 plus 3 plus 2. So we need to increment counter based on this condition, and so the code becomes very simple. Here you can see that I have described a class BT which stores the sum and the number of elements. Whenever I am striking the null root, the null node, so I'm going to have a BTB which has its sum and n. N denotes the number of elements initialized with 0. For the particular node where I'm standing, I'll call recursion to find me the left and the right sum as well as the number of elements. If this condition is true, I have declared a global variable answer which increments based on this condition. Finally, I'm going to have a result BT which stores the current sum and current n. I'm going to return that so that I can efficiently see for the other nodes of the tree. And so the time complexity for this is order of n, and the space complexity is also order of n, since I'm going to store the information for all the nodes and its children.